We're going to create 4 quadrants today using our construction tools. 1, 2, 3, and 4. In the first quadrant, we are going to construct parallel lines from congruent corresponding angles. Same thing we did before, right? This one's a repeat. Start by giving yourself a line segment. I'm going to add one little detail to this. I want to force you to make that the parallel line through a point off the line. Through point off the line. In other words, it has to go through this point. But the process remains the same. I'm going to produce a transversal. It doesn't matter what my transversal angle is. I just want a line that crosses over the line we've got and the line we want up here. I'm going to take my compass and I'm going to anchor it at this point of intersection, put the needle in there, and then I open it up so that it's some size that will cross over both my axes, both my transversal and my line. Doesn't matter what size it is. But once I establish it, I'm going to pick it up and do it again from my point that I'm trying to send this parallel line through. These are the same. They're copies of each other. Now I'm going to use my compass as a measuring tool. And I'm going to find out how wide the mouth is here. So I'll stick my needle in my first point of intersection here. And I'll adjust my compass until it's just going through the other end of this arc, where it's meeting the other ray of my angle. And I make a mark to show that I copied this. I copied this length. And then I'm just going to bring that length up to find out where it should cross here. I copied this length, and I'll go from this point of intersection and make a mark showing where it should cross here. This length copied up to here. And if I've done it correctly, I expect that I can take the point I was looking for and this point of intersection and connect them, giving myself a line that is parallel to the original line. And I'll mark it as parallel. Why is it parallel? Because I made if transversal corresponding angles are congruent, then the lines are parallel. Don't forget to mark that the lines are parallel with the arrows and that the angles we created as corresponding were copies, thus they're congruent. And again, that's what we did last class. That should be somewhat familiar. Number 2 is going to be a similar skill. We're going to construct parallel lines. But this time we're going to do it from congruent AIA through a point off the line. I'd like to see that. A little easier to see. So we start with the line again. Give ourselves a point over here somewhere, and make your point kind of on the right-hand side this time. And again, let's give us our transversal so it doesn't seem any different yet. Again, I'm going to take my compass and set it to some length. Doesn't really matter how much, as long as when I go from this point of intersection, this vertex, I make an arc that covers over both of the rays of my angle. Here's where it's different. Instead of picking this up and moving it up to this point of intersection, or this point that we started with, which is still what we're going to do, but instead of drawing that angle here, we want to spin it around so that we're drawing that angle where it would be alternate interior. We're still copying an angle. We're still placing it from this dot. It's just the positioning of where we're putting the angle that's different. So make sure that you draw this above my point, because it's got to cross over that line eventually, and make sure it crosses down over the transversal. In order to make sure that we've got the right size angle here, we're going to measure the gap between these two yellow endpoints, where our reference arc meets our rays. And we're going to copy that length to the spot from this green to somewhere up here. We don't know where exactly, but we expect that this length can copy up to here somewhere. So I'm going to start from my transversal here, and I'm going to adjust my compass so that it goes right through that point of intersection. And I leave a mark showing that I did that. And then I turn my compass over so that I can start at my point of intersection of the other reference arc with the transversal and show where that arc is going to hit up here. If I've done that carefully, I should be able to connect this point of intersection with my point and produce lines that are parallel. I'll put 2 arrows on to show that these lines are parallel to each other, but not to these over here, because these AIA angles are congruent. And what theorem did I just demonstrate? A If transversal produces AIA that are congruent, then the lines are parallel. So now we've got two ways to produce parallel lines through somewhere specific. These next two are going to be perpendicular lines. Construct perpendicular lines. Through a point off the line. Construct perpendicular lines through a point off the line. So let's begin by giving ourselves a line. And I suggest you make it kind of in the middle of your box. Don't make it way near the bottom or way near the top. Put it about in the middle of the open space. And then let's give ourselves a point that's not in the middle. Because we know how to do a perpendicular bisect. Remember the football? You go more than halfway. If I go from this endpoint and I go more than halfway, and I come from the other endpoint the same, it'll give me a perpendicular line, which is what I want, but it won't be through this point. It'll be through the midpoint. So instead, what I'm going to do is I'm going to go from this endpoint. I'm going to adjust it to go right through this point. I need it to go through this point, so I'm going to make it go through that point. And then I'm going to pick up my compass, move it to some other point here. I'm going to move it all the way to the end and adjust my compass so I go through that point again. What I produce is a nice little lopsided football now. But it still gives me the same power. I've got two endpoints. If I connect those endpoints, I'll produce a line that is perpendicular and, of course, through this point. Perpendicular. Yeah. Sure. Yeah, same there. All right, last one. Construct perpendicular line through a point on the line. And give yourself a point on the line that is not in the middle. Any ideas? Jason?
Create a like 2 points where that point is the midpoint, maybe.
Clever. Remember that we know how to find the midpoint of this whole line by going more than halfway and the same from the other side and doing our original football, our perpendicular bisector. It always finds the middle. Do we agree that this point we're looking for is the middle of some segment where this is an endpoint and there's some other point over here? So I love his suggestion. What we're going to do is we're going to put our needle on the dot and we're going to adjust it so that I can basically make a circle around this center. And a circle is the set of all points equidistant from a single center in a plane. So therefore, aren't these 2 points, the intersections with my original line, with the circle, aren't they equidistant from this center point? And so if I use those as the endpoints, forgetting about this over here, I can find a perpendicular bisector to those that'll be right through our center point. So I'll go more than halfway, make an arc, and carry that same length to the other point of intersection. And I produce this football endpoint and this football endpoint. And I expect that these will go through the center as well, because 3 points are what? Collinear. Sometimes, always, or never. Sometimes. So only if I've done this correctly will these all 3 be collinear. If they don't all come collinear, that means I've made a mistake in my construction somewhere. And that produces another perpendicular line.